Okay, so tangent is equal to sine divided by cosine. So if you take 2 pi over 3, sorry, I'm having some difficulties today with okay. So if you take the sine of 2 pi over 3 and divide that by the cosine of 2 pi over 3, that would be square root of 3 over 2 divided by negative 1/2. So when you do your keep change flip, you actually get negative root 3. So the tangent, when you take the inverse tangent of negative root 3, your first angle would be theta equals 2 pi over 3, and then we have to add that 2 pi n, because it's asking for the general formula. So what's the other angle though? Because there is another angle where it would also be negative root 3. 5 pi over 3. So that would be your answers. Okay, for question number 2, when you take the reciprocal, that would be 3 over 2 root 3, and you rationalize that, you would get 3 root 3 over 2 times 3, which is 3 root 3 over 6. And that would reduce to square root of 3 over 2. So, secant is the sister to sine. I'm sorry, no it is not. Take that back. Secant is the sister to cosine, okay? So you're going to look at your unit circle and tell me where on the unit circle is cosine equal to square root of 3 over 2. So where on the unit circle is cosine of theta equal to the square root of 3 over 2? It's the same question. So when you take the inverse secant, theta equals the inverse secant of 2 root 3 over 3, or you could say theta equals the inverse cosine of root 3 over 2. So go ahead and tell me where on the unit circle do we have that. So I'll give you a second to look at that. So there's 2 angles that have a cosine of square root of 3 over 2. So your first one would be pi over 6. And then again, we have to put that plus 2 pi in because it says general formula. And the second angle would be, okay, and that is that. So about half of the quiz is solving equations. So we have probably solved the equations that will be on the test in the last few days because there's only so many different types of questions we can ask. Okay, questions or comments about our bill work?
How long was the first one?
So take a second, copy down these 2 questions. think these are our last two. So these will take a little bit of space, so you might want to only copy down one question to give yourself some room, because we have to factor. Because it says 2 sine squared minus 3 sine theta plus 1 equals 0. So this is a quadratic that we have to factor. So I think just to make it easier, what I like to do is do what I call a U substitution. So what I'm going to do is say that U, I'm just picking the variable U. You can use any variable. U equals the sine of theta. Okay, so I'm going to use that and then rewrite this as just a simple quadratic that's easy to factor. So let's rewrite this as 2 u squared minus 3u plus 1 equals 0. Because I think it's easier to factor if we don't have those signs in there. Go ahead and factor that down. Factor and solve that quadratic equation. So factor 2u squared minus 3u plus 1 equals 0. So take a minute and factor that down and solve it. So we need two numbers that multiply to 2 and add to -3. So what would be our numbers? They have to multiply to be A times C and add to B. So I know, yeah, we don't have calculators, but what would be our numbers that multiply to be 2 and add to -3? -2, -1. That's the only thing that multiplies to be 2 is 1 times 2. So we have a -2 and a -1. And I think the majority of you all factor with a box, so I'm going to factor with the box. So 2u squared would go here. +1 goes here. And then -2u and -1u. So let's take out our GCFs. So when I take out the GCF in this top row, that would be 2u. And the bottom row is -1. In this column, that would be a +u. And in this column, it's a -1. So you have 2u minus 1 equals 0. Go ahead and solve that. And u minus 1 equals 0. So solve both of those equations for u. And you should get u equals 1/2 and u equals +1. So now let's go ahead and put this back in, because u is really sine. So really what this is the sine of theta equals 1/2. So theta is going to equal the inverse sine of 1/2. And then for our second equation, sine of theta equals 1. So theta equals the inverse sine of 1. So let's start off with the 1/2. Go ahead, look at your unit circle and list all of the places where sine is positive 1/2 and then where is sine equal to 1. And that would be your solution. Okay, so where is sine 1/2? Sine is positive 1/2 at pi over 6. And it says, let's look at the interval. The interval says from 0 to 2 pi, which means we don't need to add that plus 2 pi in. So make sure you're checking the interval. Okay, so my first solution, and I'll write it, at the top, is theta would equal, so where is sine equal to positive 1/2? The first place is pi over 6. And then where else is sine 1/2? 5 pi over 6. And then where is sine equal to 1? Pi over 2. And those are your 3 solutions right here. Okay, so the first thing I'm going to do is subtract the 1, because with every quadratic, remember, going way back to algebra 1, you cannot factor unless it equals 0. So we need to make it equal to 0. So we're subtracting the 1 first, which is going to give me 2 cosine squared theta plus cosine theta. And is it going to be a plus 1 or a minus 1 at the end? Okay. So again, this is just me. I like to rewrite it. This is optional. You don't have to do this on the test. But I just like to rewrite it. So u equals cosine theta. So now we're dealing with cosine. So I'm going to rewrite this as 2u squared plus u minus 1 equals 0. All right, go ahead and factor and solve that quadratic. Okay, so you should have 2u minus 1 equals 0. So u equals positive 1/2. So we're going to look for where is cosine equal to 1/2. And then my second equation was u plus 1. So I need to know where is cosine equal to negative 1. Because cosine is u. So cosine theta equals negative 1. Theta equals the inverse cosine of negative 1. So look at your unit circle and tell me where is cosine equal to negative 1. Write that down. And then for my second equation, cosine theta equals 1/2. So tell me where on the unit circle is cosine 1/2. So there are 3 solutions that we will be looking for. So go ahead and find those 3 solutions. So let's look at the 1/2. Cosine is 1/2 at pi over 3. And it's also 1/2 at 5 pi over 3. And where is cosine negative 1? Pi. At pi. So that would be your 3 solutions. Who had those 3 solutions? Okay. So the one thing that I do want you to write down, we have one more question that I think I do want to squeeze in because tomorrow we're going to start reviewing for our test. So I want to go over, I think the one that is kind of worth the most amount of points, and that it involves the Pythagorean identity. So take a second, and you don't have to copy down this whole diagram. This is just an explanation as to why this is true. But go ahead and copy this down. This is the Pythagorean Theorem, which you're used to working with. A squared plus b squared equals c squared. But if you take this a squared plus b squared equals c squared, and you write it in terms of the unit circle, this is your identity because c is 1. Okay, so sine squared plus cosine squared equals 1. Write that in your notes. Highlight it, put a big box around it, because we're actually going to use that a lot. So this is the Pythagorean identity, which is what is derived from the Pythagorean theorem. So using it in terms of sine and cosine. So sine squared plus cosine squared equals 1. And there is one equation where you will have to use this in order to solve, in order to factor. So I want to show you an example of what that is going to look like as we prepare for Friday's quiz. And this will be our last question. So it's the Pythagorean identity. So sine squared is A, cosine, well in this diagram, sine squared is A, cosine squared is B, and C is 1. 1 squared is still 1. Okay, so our last question, do we all have that identity? Just what I have highlighted in pink. That's the main thing. All right, copy down this very last question. Let's do A. Yes. It's called the Pythagorean Identity. And I'm going to rewrite it up here too. Okay, so the reason why we can use it in this example, notice that we have a sine squared, right? Sine is squared, cosine is not. So I can't take out a GCF. The only way I can do this question is if I do a substitution. If I replace the sine squared. So I need to replace sine squared. So if I were to take this identity and solve it for sine squared, how would I solve this for sine squared? What would I have to subtract? To solve this equation, this identity for sine squared, I would have to subtract cosine squared, right? So if I subtract cosine squared from both sides, then we would have sine squared equals 1 minus cosine squared. So it's important to know that identity, sine squared plus cosine squared equals 1, because we can rearrange that identity. We can take that identity and solve it for cosine, or we can solve it for sine. In this example, because it said sine squared, I'm going to solve it for sine. So this 1 minus cosine squared is equal to sine squared. So what we're going to do is substitute 1 minus cosine squared in this equation for sine squared. So this is what we're going to have. We're going to have 3 cosine theta plus 3 equals 2, because I need to write this in terms of either all sine or all cosine. Now, in that parentheses, I want you to put in 1 minus cosine squared. So this 1 minus cosine squared is going to drop right here.
Why are we doing substitution?
So we need it to be written in terms of all sine or all cosine, because you cannot factor it. So for example, thinking about this in terms of algebra terms, if this was written as 3x plus 3 equals 2y squared, we couldn't factor something with 2 different variables, right? We need this to be written in terms of one variable. So I needed to do a substitution, so now it's all cosine, so we can factor it, okay? So now, let's go ahead and distribute that 2. When I distribute the 2, and these are a little bit, this is, like I said, like I'm, being honest. If I had to say, what's the hardest question, this is it. And that's why I want us to practice with it today and tomorrow. So 3 cosine theta plus 3 equals, so we have 2 times 1, which is 2, minus 2 times cosine theta, 2 times cosine squared theta. So that's where I am. So I think what I want to do right now is go ahead and do my U substitution, because this looks intimidating. So how about we go ahead and rewrite this using a variable that's not cosine, so we can solve it algebraically. So at this point here, I want to rewrite this. I'm going to take out the cosine and use U. So U equals cosine theta, because it just looks a little bit less intimidating. So we have 3u plus 3 minus 2u squared. Oh, wait. 3u plus 3 equals 2u minus 2u squared. So now we need to solve that. So bring everything to one side so we can factor it. So the first thing I'm going to do is add the 2u squared. I'm going to bring that over. And then I need to subtract the 2. So we end up with 2u squared plus 3u plus 1 equals 0. Okay, go ahead and factor that down. So who had this as their factors? 2u plus 1 and u plus 1. Who had that? All right, go ahead and solve those for u. And remember, what does u equal? What trig ratio does u represent? Cosine. So now go to your unit circle. Tell me what angles have a cosine of -1/2. And also what angles have a cosine of -1. So what angles has a cosine of -1/2? 2 pi over 3 and 4 pi over 3. Who agrees with that? And then what angle has a cosine of -1? Pi. That would be your solutions. So we're going to practice this more tomorrow, where you have to substitute and then factor it down. But again, as far as difficulty, I think this is the hardest one. You do have homework 8 is due tomorrow. Make sure when you're turning in your homework that you have the trio, name, period, and homework number. That just makes sure that I get it to Skyward in the right column for the right person. Without those 3 things, I usually just give up because I don't feel like trying to figure it out when I have 150 kids. Okay, if you have questions right now, I'm here to help. That's it.